Hello everyone. So from today I'm going to start Cadence algorithm playlist. Okay. There won't be more than 3 videos as per my expectation on this use case of Cadence algorithm. When is Cadence algorithm used? So when you are given the array of nums, okay, positive and negative, both value, positive and negative, both values could be present. And if you want to find maximum or minimum sum subarray, so you need to find subarray who has the maximum sum or minimum sum, and you need to return that maximum sum or minimum sum. Then this cadence algorithm is mostly used. Okay, so it is again related to, if we see the main keyword, then when it is used. So there are two key points which we can take out of this: when both positive and negative are numbers are given. So when both positive and negative numbers are given. And the second case is when something related to subarray, sum of subarray, we need to find out. Okay, so the same condition which we have found in prefix sum using map, there also both this are allowed, and something related to sum of subarray is also allowed. So now what is the differentiation? And even in sliding window is also related to some condition on subarray. So you need to find the maximum length of subarray or minimum length of subarray, and we have seen a lots of videos. So I'll better suggest you to go through prefix sum first, then sliding window, and then Kadans algorithm to understand the difference between all these three. Okay, I will be covering the differentiation between all these three algorithms, when to use what in separate video, but just to give you a high note on this. Okay, so when only positive or only negative numbers are given and some condition k given. Okay, it could be at least or at most, or some condition k given, which is not some specific, which is not some specific or addition specific, I could say. Then then you can use this. Then you can use what? Sliding window. Then you can use sliding window. Sliding window can't be used on mixture of both positive and negative numbers. No, we cannot use that. Okay, and also it can't be used on some specific conditions. Some specific conditions it could be used, but it would be easier to use prefix sum using map in those cases. Okay, so when both positive and negative are given. Okay, when both positive and negative are given. Oh, sorry. And some fixed sum k is given, or that is given, or explicitly you find that. Okay, or explicitly you found, that means you found that condition, that there is some k which we need to find out. So we have seen all those type of questions, that how we will explicitly derive from the question given that okay, this is the sum related to prefix sum using map, and some fixed sum of k is forming out of this question. So there we can use prefix sum using map. So there we can use this method of prefix sum using map. And now the third case. So when both positive and negative are given, so values, these are the values which are given, and not fixed condition on k is given. So the condition be like find maximum sum or minimum sum of subarray. Those could be the conditions. So there we will use what? Cadence algorithm, which we will be learning today. Okay, now people do prefer that Cadence algorithm is nothing but just a simple template where we need to do this all, the 3 step code, that's it, and we are done with it. But it's not like that. And then the students get confused when the interviewer asks the follow up questions, which they will mess up. So let me be clarify with you. Now this all we have learned, and let me just explain you the brute force approach also for the Cadence algorithm. So the question you have understood, right? The basic question of Cadence algorithm is to find the basic question is to find maximum or minimum sum subarray. So you need to return whether the maximum sum of subarray or minimum sum of the subarray. Okay, so the brute force will, you will be calculating for all the subarrays. You will calculate the sum, and whichever is the maximum or minimum as asked in the question, you will return that. So to find all subarrays, you need to run two loops, which will be order of n square, big O of n square. Now we will move on to the optimized approach, which is Kadane's algorithm. Okay, so there are four different templates. To be sure with you, to make sure, there are four different templates. Okay, so the first is to find the maximum sum subarray, that too when empty subarrays are allowed. Now why I am specifying this? Okay, so let's say, now just remember that Kadam's algorithm will always work for any type of numbers, positive, negative, zero, anything. Okay, so the question says maximum sum subarray we need to find, but the empty subarrays are allowed. Now what does this mean? This means if if all values are negative, if all values are negative, we can return answer sum as 0, which is maximum for empty subarray. If all the values are negative, then you think, if all values are negative, what could be the maximum sum? Nothing. I can't do anything. Okay, I cannot take anything. If I want to find maximum sum and empty subarrays are also allowed, then I'll not take anything. I'll just take empty subarray which has the sum of 0, nothing but the sum of 0. So I'll return that answer as 0. This means when empty subarrays are allowed, then this answer sum has to be 0 for empty subarrays if all values are negative. So we'll have the different template for this. And if it is mentioned specifically that we are not allowed empty subarrays, so only non-empty subarrays are allowed, then there is a little bit change in the template which we will be doing right now, which I'll be explaining you right now. Okay, so let me just give you an example. So let's say our nums is given as -1, -2, 1, -3, 4, 5. Okay, I'm not taking all negative. Okay, I'll be using this template only for all four different types of templates. So what we will be doing basically in Cadence algorithm, let me just generalized steps mentioned over here. What we will do, we will calculate sum as and when we go forward. So we'll calculate the sum. So we are at here, we'll calculate sum as -2. So sum from 0 to I. This will be basically sum from 0 to I. And now there could be two steps. First is calculate maximum or minimum sum. Okay, so you will compare it with the maximum answer or minimum answer. Okay, whether the sum is maximum, then we'll update or minimum. And the third step, if sum is less than 0 or sum is greater than 0. So if asked for maximum sum, then if at all our sum goes beyond if our sum goes in negative direction, that means until now I have got some positive, so I've updated. Now if at all I'm taking this ith subarray, then my sum is going in the negative direction, sum becoming less than 0. Now that couldn't be the maximum sum at all, that couldn't be possible. So I'll break the loop at this point. What I'll do, I'll break the loop at this point. So I'll break the loop. What does this mean, break the loop? Break the loop means I will make sum as 0 again. So I'll reinitialize the sum to 0 again. So now I'm not taking this, I'm reinitializing it to 0. This is what I'm doing. Now this 2 and 3 steps could be changed depending on whether the empty subarrays are allowed or not allowed. So if the empty subarrays are allowed, then what we will do, we will first of all check this. If sum is going uh, beyond 0, if sum is going less than 0, then we will update that sum to be 0, and then only we will calculate the maximum or minimum sum. But if the empty subarrays are not allowed, only non-empty subarrays are allowed, then we will first calculate this maximum or minimum sum, and then we will update these changes. Why? Because if only non-empty subarrays are allowed, then what could be my answer? If all values are negative, I need to return one value which is as maximum as possible. So let's say it's given -2, -3, -1, -4. So what could be my maximum sum out of this? -1. So whichever is the smallest value in negative side, okay, that I need to return. Or I can say whatever is the biggest value out of those four, that one value I need to return. So I need to compare or calculate this maximum or minimum sum before initializing the sum to be zero while doing this sum condition. Fine. So applying this rule over here, let's say we have this. So our initial sum, now the initialization also matters. So when we are doing maximum sum subarray and empty subarrays are allowed, if empty subarrays are allowed, okay, we will initialize our maximum sum, that is the answer, to be 0. Initialize max answer as 0 if empty subarrays are allowed. Okay, now what are we doing? We are just going under this loop. We will be doing the summation. Now the first step, if the values, if the empty subarrays are allowed, then at the first only we will be checking if sum has gone less than 0, we will initialize it to 0, because maximum answer is what I can get, non empty subarray, if all are negative. Okay, and if any positive is given, then this 0 is minimum answer. I can get at least the summation of positives as the maximum sum subarray. I didn't want to include any negative under that. Cool. Okay, and now I'll do maximum as maximum sum, or maximum sum as maximum of what we have got until now and this sum, and we will return this maximum. So let's go and dry run this. I'll be doing dry run for this one approach, and then you will understand all four templates very easily. Okay, so currently our sum is 0. Our sum would be -2 when we are at this point. Okay, so sum is -2. Sum has already become less than 0, so we'll do sum as 0. This means it's no need of taking -2 in any of the subarray. So there are no elements before -2. So anyways, we will be not be considering this. After -2, we can take anything, but not -2. Why to take -2? It will anyways decrease my sum, right? So we will just put the sum as 0 at this point when our sum has become less than 0. This applies to every point. So whenever our sum becomes less than 0, we don't want that part, because anyways they are decreasing our sum. So we'll make it we'll make it as 0. So our sum has become to 0. Maxi is again 0 only. Now the sum has become 1. So sum is not less than 0. Maxi will be comparing it with the original maximum sum, which is 0 and 1. So this will be 1 now. Okay. Uh, Let me do it over here again for your understanding. Okay. Fine. Now we are at -3. So 1 minus 3 minus 2. Again, it is doing the sum as -2. So I don't want this. So I'll compare. Sum has become less than 0. So I'll make the sum as 0 again. I'll compare it with the maximum sum. Maximum sum is already -1. So if you consider this 3 only, okay, do not consider 4 and 5 as of now. If you consider this 3 only, then it will be always better to take only one as your subarray and as your answer, which will be contributing to max sum as 1. Now I'm moving to this 4. So sum will be 0 plus 4, which is 4. Okay. Comparing it with this, my maximum also will become 4. And now my sum will be 9. Comparing it with this, my maximum sum will also become 9. So maximum sum is 9, and the original answer is this subarray 4 comma 5. Now I can take this subarray also, 1 minus 3 4 5. Sum is becoming positive only. But we have seen that if I am taking this 3 subarray, my sum is becoming negative. So it will always, which what is the sum I'm getting if I'm taking this 2 only, let's say -2. So if at all I'm adding this -2 to 4 plus 5, it is always decreasing only. So we are putting this condition of whenever it is becoming less than 0, we'll be doing it as 0. Okay, and your maximum is updating But this will allow when all these are minus 1. Let's say all of this are minus 1. So minus 2, sum is less than 0. We will do sum is equal to 0. Maximum sum is this. So it will not be updated anytime because empty subarrays are allowed. Every time the sum will become 0 because the sum will not become positive at any point of the time over here because all are negative. So you are done with it. You will get your maximum answer as 0 only in this case. Clear? Okay, we are with this. And let me remove this. Fine. Now we are coming to our second template, which is maximum sum subarray only, but non-empty subarrays are only allowed. Non-empty subarrays are only allowed. So here I need to initialize my max sum to be as negative as possible. Initialize max sum to be as minimum as possible, I can say. As minimum as possible. So these are the integer values in my nums. Okay. So minimum integer value is -1e9. So I can initialize this with -1e9. So 10 minus 10 raised to 9. Or minus int mean you can assign. Okay. Minus int mean you can assign. Not minus int mean, just int mean. You can assign. Why? Because now it said that non-empty subarrays are only allowed, so we cannot make it 0. If at all we'll make it 0 every time, if all the values are negative, maximum will remain always 0. No, that shouldn't be the case because 0 is always bigger than any of the negative values, right? So it will not update, so we need to initialize it to as minimum as possible and our sum to be 0, of course. Now what we will do, I'll go now. This thing is okay. I'll do sum plus equal to nums of I. Before checking sum less than 0, I need to update once this maximum sum. So I'll update this maximum sum to be whatever is the maximum sum I have got. And now I will replace this. So if sum is less than 0, I'll make this sum to be 0. Now what happened? If all these numbers are negative, okay, -2 and -1, -3, -4, -5, then for -2, my maximum will be updated to -2 first. Okay, just assume that you will be given this case. Okay, it will be updated to -2 first. Sum has become again 0. Now I'll do sum plus equal to again. So now sum, it has become 0. So now sum will be -1. Compared it with -2, it will become -1 now. Again sum will become 0. Then I'll compare it with -3. Sum will be -3, but maxi will not update. Sum will again become 0. Sum will be -4. Maxi wouldn't be updated because -4 is less than -1. Sum will again be 0 and same for the -5. So your answer will be -1. Because non-empty subarrays are not allowed, this is your answer. Okay, -1, whichever is the maximum number in full subarray. So this is the change which you need to do. And this change, because if at all I initialize this with 0, always this will be 0 because it is comparing. So this I need to assign as minimum as possible. Okay, the same thing for minimum sum subarray. Okay, just update the maximum with minimum. So minimum sum subarray, if empty subarrays are allowed. Okay, if empty subarrays are allowed, then if here the case is for if all positive values are there. If all positive values are there, answer needs to be 0. Because if at all I take empty subarray, then only my sum will be 0, which is minimum of all because all values are positive. So sum will anyways be something positive. So what I need to do here also the same case. You will assign this minimum answer to be 0 in this case, and sum also needs to be 0. And while going in the loop, the same thing. You will do the summation, but you won't update first. You will update your sum first. So if sum has become greater than 0, the condition become opposite of here. Okay, then we will do sum as 0, and then we will update our minimum answer as minimum of minimum answer comma whatever sum we have got. But our fourth condition, where minimum sum subarray only we need to find, in that too non-empty subarrays are only allowed. Okay, So if the condition says that non-empty subarrays are only allowed, so in that case, if all positive values are there, we need to take a positive value which is as minimum as possible. Clear? So we will assign this minimum answer to be as maximum as possible. As maximum as possible. So it could be int max or 1e9 plus 1e9. Okay. And sum needs to be 0. Now the same thing, you will be doing the sum plus equal to nums of I. Okay. First you will compare it. So minimum answer is equal to minimum of this minimum answer, whatever you have, and this sum. And now you will change this sum. So if the sum is greater than 0, we'll do this. So these are the four different approaches which interviewer may ask you the follow-up question, and you may get confused that okay, why we have to do this. Anywhere you will see, you'll be seeing one template only. This template, basically this template which people shows mostly for non-empty subarrays. But it could be the case that you'll be given that empty subarrays are allowed. Then what are the changes you need to do? The change in initialization and the change in the step 2 and step 3. These are the changes you need to do. So for all of this, we will be running only one loop. So our optimized time complexity has become order of n. I hope you got this. Okay. I'll be pasting the link in the comment section below, description section below, for the simple Kadane's one question of Kadane's algorithm in GFG. You can go and write the code over there. It will be easy. Just the simple template, nothing else. If you will remember this too, for maximum, for minimum, you'll automatically learn. Fine. So I'll be coming in the next video with with the bit intermediate level question of Kadane's algorithm. Okay, people have understood only this as the Kadane's algorithm. No, there are some questions which will be using this question as the base reference, and it has been created. Okay, so I'll be coming in the next video with a little higher level of Kadane's algorithm. Stay tuned until that. Do like, share, and subscribe if you have learned a lot out of this. Stay safe.